right, hello everybody. So I got a question about vectors and about using the scalar product or the dot product to figure some things out. And so here's the situation. We've got a vector called A and we've got a vector called B. And what we want to know is we want to know theta. We want to know theta that's between A and B. Okay, so I write like this. Theta that depends on A and B. Okay. And what we know, for some weird reason, I'm not sure why we would know this, but we are told that A minus B is perpendicular to 2A plus B. And we are also told that A minus 2B is perpendicular to 3A plus B. So if I know two vectors are perpendicular, then I know they meet at a 90-degree angle. And remember, our definition of the dot product is just that A dot B. Um, you can use the geometric definition where you get magnitude A, magnitude B, cosine of theta. So if A is perpendicular to B, then theta has to be 90 degrees. Cosine of 90 degrees is equal to 0. So A dot B equals magnitude A, magnitude B times 0. In other words, A dot B equals 0. So if they're perpendicular, then their dot product equals 0. And so let's try it. Let's look at this first one here. This first condition tells me that A minus B dot 2A plus B equals 0. And so what that becomes then is just distributing. One of the properties of the dot product is that you can distribute it. So we're just distributing it like we would with a normal polynomial. So 2A dot A would be 2A squared. And really, I shouldn't use squared there because what does it even mean to square a vector? What I'm saying is if you do A dotted with itself, let's look at that real quick. A dotted with itself is going to be the first component of A times the first component of A plus the second component of A times the second component of A. And if it's a three-dimensional vector, we'd have the third component times the third component. In other words, it's the square of the components, either 2 or 3 of the components. In other words, it's the magnitude squared. So I'm just going to put those absolute value bars there. So I have 2 magnitude of A squared, and then I have plus A dot B minus 2A dot B minus magnitude of B squared. And that all equals 0. Simplifying that, we can say 2 magnitude A squared minus A dot B minus magnitude of B squared equals 0. Let's play the same game with this other condition. So we have A minus 2B dotted with 3A plus B equals 0, implying 3 magnitude A squared. This will be negative 6AB, and this will be positive AB. So I'm going to simplify to negative 5A dot B. And then minus 2 magnitude of B squared also equals 0. Okay, let's see what we can do here. What I notice is that, a couple ways you could approach this. I guess what I'm going to do is do substitution here so that this is equal to the magnitude of B squared. And then I can substitute this chunk here. And let's create a little bit more space. Get out of here, purple corner. I wish that my eraser was more effective, but here we are. Okay, great. So if I sub that in, then I have 3 magnitude a squared minus 5a dot b minus 2 times magnitude of b squared, which is the substitution part I just did there. So negative 2 mag a minus 2 a dot b, and that all equals 0. If we distribute, then this makes this into negative 4, and this makes this into positive 4. So negative 4 would mean I have 3, and minus 4 would mean I have negative 1 magnitude of a squared. And then if I have a positive 4, I'd have minus 1 a dot b, and that equals 0. And so if I solve for that, I can say a dot b equals magnitude of a squared. Or I guess negative magnitude of a squared. Okay, gotta be careful there. Okay, so if it asks me about the theta of a and b, then I can use the other definition, the geometric definition, and say that that negative magnitude is also equal to magnitude a, magnitude b, cosine theta. And so then I know that cosine theta is equal to negative magnitude a divided by the magnitude of b. Interesting. I thought that was going to simplify out a little bit nicer. Let's see, did I do something wrong? I don't think I did something wrong. Am I missing something here? I'm going to pause and think for a second and then come back to it. All right, so I found a small error that I made here, that when I copied my substitution over, I have a single AB here, not a 2AB. So let's cut that out. And so that makes that into a positive 2. That makes this into a 3AB. And this just means that, let's do this. Let's create a little more space. Let's clear this out. What we're going to do is get a equation for the magnitude of A and an equation for the magnitude of B. And then we'll use that to find the theta. Okay, so we'll be okay here. So from this equation here, I can get that the magnitude of A squared is negative 3A dot B. And if I substitute that in to the equation for the magnitude of B squared, then I can get that I have 2 times magnitude of A squared, negative 3A dot B, minus A dot B equals magnitude of B squared. In other words, what is that? Negative 7 A dot B is the magnitude of B squared. And we also know from our geometric definition at the beginning that A dot B is magnitude A times magnitude B times cosine theta. In other words, theta is going to be the inverse cosine of A dot B divided by magnitude A. So arc cosine A dot B over, well, let's do the square root here. So the square root would be the square root of negative, negative 3 A dot B times negative 7 A dot B. Here we can have the A dot B cancel because there's the square root of it squared on the bottom. So we have to do the arc cosine of 1 over the square root of 21. And if you type that into your calculator, the arc cosine of 1 over the square root of 21 is 77.4 degrees. Okay, so tricky question using the dot product to find the angle between two vectors.